Welcome everyone. In this video we're going to be going over OSPF not so stubby areas. Now, what are not so stubby areas? Well, if you watched the last video, you'll know that I have two areas configured on my network. R1 and R2 are in area 1. The rest of the routers are all in area 0. R1 has a loopback interface that it's trying to do redistribution into OSPF on. In the last video, we saw that when we configured a stub area, this redistribution was not allowed to happen. The command was still there, but no Type 5 LSA was generated, and none of the routers in Area 0 knew about R1's loopback. And that's because of how stub areas work. A normal stub area is going to filter out Type 5 and Type 4 LSAs. A totally stubby area, it fills out Type 3, 4, and 5 LSAs, and again, no redistributions allowed into the area. So that's why we have the not so stubby area. Excuse me, the not so stubby area. So the first thing we'll do is take a look at R1, and we'll just see the current state of the network. So we'll do a show IP route for OSPF, and I took off all stub commands so you could see we're learning the full topology, and you notice that the next hop for every single route is the same because it's R2. I mean, we look at the topology, we can see that if R1 wants to get to any of the other routers, it's got to go through R2. So we saw in the last video, one of the things we could do is come into OSPF and we configure area 1 as a stub. But in this case, we're going to configure area 1 NSSA, which is specify an NSSA area, which is a not so stubby area. NSSA, show IP OSPF neighbor, and we can see the neighbors down because the NSSA command works the same way as the stub command, where it puts the stub flag in the hello packet and the neighbors drops. So again, on here, we'll go to R2, router OSPF1, area 1, NSSA. Okay. Now the neighbor is up. And let's go ahead and look at the show IP route for OSPF. And we can still see we have a bunch of routes. But if we look at the IP OSPF database, we could see now that we don't have any Type 5 or Type 4 LSAs. We have a new one called Type 7, which is interesting. And we still have the Type 3s. Because remember, we didn't... I'll show you in a moment, but just like a regular stub area, a regular NSSA does not filter out Type 3s. It just filters out the Type 4 and 5s. But now we have this Type 7. And what is that? Well, it's an external link state for an NSSA area. So if we go to R2 and we look at the database here, show IP, OSPF database, we could see here we have our Type 5 LSAs and our Type 7 LSAs, which is interesting. So the way this works is as follows. Let's get out. Okay. So R1, as we saw, redistributes into the NSSA. Since it's doing redistribution inside an NSSA, which does not allow for Type 5 SLAs, it actually does it as a Type 7, which then sends it over to R2. Now, R2 is in Area 1 and Area 0. It's our ABR. Learns the Type 7 within this area. The other thing it does is it does a Type 7 to 5 translation. And that is this Type 5 link for 1.1.1.1, and the advertising router is 2.2.2.2. And that's so that R2 can take the Type 5 LSA and advertise it to all the other routers in Area 0. So if we took a look at, and let me get rid of this. If we take a look at these LSAs, we can see they're similar but a little different. So let's do a show IP OSPF database, and we'll do an external for 1.1.1.1. Here's our Type 5 LSA. We can see the advertising router is 2. So all the routers inside area 0 know that in order to get to this route, they have to go through 2. Now let's take a look at the NSSA external route, and this one is a little bit different. So it's show IP OSPF database, and we could see that there's a new flag here, an NSSA external route. So NSSA external. And it's pretty similar, but we do have a couple other things to look at. So, yes, the advertising router is 1. We still see that the metric type is 2. It's an E2 route, and the metric is 20. It's the same thing as a Type 5. We could see the forwarding address is not all zeros. It's 10.0.12.1, which is this link here. So it's a little bit different than some of the Type 5s that we saw earlier, where the forwarding address was all zeros, and in that case it would use recursion to look up the Type 1 LSA for here. In this case, the recursion looks a little bit different, but for now, we'll just notice that it's the forwarding address is the link and not the node. Then we can see here Type 7 to 5 translation. So this is what's allowing R2 to take that Type 7 LSA and turning it into a Type 5. It is possible to turn that off, but by default, it's on. So let's go ahead and get rid of some of this. Go back to R1 and let's just take another quick look at the database. All right, so we could see that we're allowed to do redistribution into the NSSA. We can see that the routing table didn't shrink too much. All it did was take out an external route that, in this case, we only had one external route coming off R6. It took that out of the table. So let's try to shrink this down even further. So we know that with the regular stub areas, we could do what's called a totally stub. We could do something very similar with a not so stubby area. Area 1, NSSA, and again we have that no summary. Do not send a summary LSA into the NSSA. This turns the not so stubby area into a totally not so stubby area, which I realize the name is kind of, I don't know, there's been a million jokes about how what the name is like, but regardless, it is now a totally not so stubby area. So what this does is, if we go back into R1, take a look at the database, which will take a second to converge. Let's try it again. All right. So now that we're reconverged, we can see that the OSPF database is much smaller. We have our 2 routers that are within the area. We have our Type 3 LSA that R2 is advertising. So remember that here on R2, we're blocking, or we're filtering out, I should say, Types 3, 4, and 5, but we're still advertising a single Type 3 for the all zeros network. So we're advertising a default route. And then we have our Type 7 LSA, which is the external route that we were advertising. So you could see that the totally, or the not so stubby area and the totally not so stubby area work very similarly to a regular stub network. The only difference is we're now allowed to do redistribution. So now that we have this ready, on the next video, we'll kind of go over some of um, the recursion in the database with a type 7 external link.